Hi guys, I'm bored. Let's calculate the elastic force of Itswapi. First of all, the reason why in Itswapi is because your bums have something called movement and friction. So as you walk, right, um, it's rubbing on the fabric, back and forth, and then it just kind of vacuums your under yakho, in between. Now, elastic force is basically the restoring force that a fabric or an elastic material exerts when stretched. In order to calculate this, we would have to use Hooke's law, right? Which basically surmises that elastic force is equal to the spring constant, which is the stiffness of the material, multiplied by the amount of stretch in meters. Let's start with the amount of stretch. Obviously, this is going to differ according based on the size of your posterior, but let's assume that the fabric stretches for around 5 centimeters, which would be 0.05 meters, right? That's our stretch, that's the amount of stretch. And then the spring constant really depends on the material itself, right? I would say a conservative amount of stretch would be 100 newtons 100 newtons per meter, right? Now that we have all our variables in place, we can go ahead with the calculation. Remember, according to Hooke's law, elastic force is equal to the amount of stretch multiplied by the spring constant, right? And so to calculate the elastic force of the tswapi generated by the tswapi in this particular scenario, then all we need to do is multiply 0.05 meters, which is our stretch. We multiply that by 100 newtons per meter, which is our spring constant, right? And that gives us around 5 newtons, which with a little more creative mathematics can power a 5-watt light bulb for 1 second. Your topic can power up a light bulb for 1 second or lift like half a kilogram of something. I don't know.